So you heard from our prior speakers about that, there's real opportunities and there's some real challenges from a policymaker's point of view. Next slide, please. Really wanted to look at early examples or existing examples of installed heat pump water heaters to address one of the most fundamental uses of gas in commercial kitchens is producing hot water in addition to the cooking process. And as we looked around, we were unable to find those examples. And so that really begged the question, why? And has yielded some interesting insights. So I'll go through quickly. Next slide, please. So for background, as we alluded to before, as local governments, we talk a lot about the policy drivers at the state, local, and regional level that are pushing for decarbonization. We are all familiar with the efforts of REACH codes as well as the recent challenges. We are aware of the de facto gas ban, the BACMED requirement to eliminate NOx emissions from water heaters and furnaces in common sizes. You have the CPUC perhaps not being so helpful on the rates front, but at the same time, really reducing the capital cost incentives to supply gas when building a new building or putting in new lines even to renovate an existing building. The Energy Commission has made heat pumps the baseline for both gas and water heating in new construction in the 2025 code, as well as begun to address heat pumps in baseline conditions in some commercial and multifamily, commercial and residential settings at time of either a replacement or renovation in the code. And there's plenty of detail you hear about as that proceeds through the process and is finalized. But that's partly in service of the state's goal to get 6 million heat pumps installed statewide by 2030, as well as to launch and offer enhanced programs for helping those who need the most help with decarbonizing their buildings. And then you have the Air Resources Board addressing the same set of issues, partly directly regulating carbon emissions under their authority under AB 32, as well as beginning to work on their own zero emission appliance rules. So all that context, where are these water heaters that would be beginning to even approach the type of efficiency Michael was alluding to is necessary? Next slide. And it turned out there was a whole different set of regulators. If you're able to advance the slide, I appreciate it. Excuse me. Let's stick with this one for a second. There were a whole different set of regulators who are managing an entirely strongly related, but a little bit different issue. So what I'm used to working with our building officials on building safety codes and on the energy code. But it turned out that a significant challenge for heat pump water heater adoption is compliance with some health regulations. And before we get into those regulations themselves, it's worth bearing in mind why we have them. That in this image, we have an image of the norovirus. This is the most common source of diarrhea, of other stomach upset and sickness. It is one example of a pathogen that is commonly spread between humans, either from lack of hand washing or challenges in washing utensils and cookware that have been used for eating. Next slide. And so really to address that public health challenge of not spreading pathogens amongst one another, the California Retail Food Code requires any sort of food service facility that's regulated to have adequate hot and cold water, and that it be available on a continuous basis at any time at 120 degrees Fahrenheit minimum as measured at the point of delivery, so at the faucet or other type of fixture. And these requirements are enforced by by county health departments. Next slide. And there isn't where the state energy code has the Warren-Alquist Act kind of making the similar sweeping requirements. And then the energy code is hundreds of pages of detail explaining exactly how to adhere to California's energy standards. On the health front, there isn't a similar regulation fully explaining the technical detail of how to comply with the California Retail Health Code, Retail Food Code, or similar codes. Instead, the county health directors have their own organization, the CCDEH, and they have really worked together to advance uniformity and best practice. And they have developed technical guidelines, which have been adopted by all 58 counties throughout California. So this is a plan review process that looks at what I might consider an energy system, but it's reviewed for safety by health staff who are, worth bearing in mind, experts in environmental health, not in plumbing or energy efficiency. Next slide. The guidelines boil down to figuring out exactly the maximum possible amount of water that you could, sorry, exactly is a little bit of a misnomer. Anyway, calculating the maximum possible hot water demand for the facility, given some prescriptive criteria. But that's fundamentally assuming that you'd have all the taps and equipment in use continuously. And then there's an adjustment depending on whether you're also providing washing for eating utensils. And then your water heating system must have capacity to meet that potential maximum demand. If we could advance, there's a quasi animation here. And the guidelines provide two paths. One could either do some relatively straightforward math, or they can look it up. But the input capacity, as you can see in the table at the bottom, input capacity for a water heater that's not using gas is based on kW of electric input. So there isn't a specific guidance for heat pumps. It's really fundamentally designed around electric resistance to make it simple to determine whether electric resistance water heater is big enough, or a gas water heater is big enough to meet these guidelines. Next slide. So the challenge is heat pumps are a totally different technology, and you'll hear more about that in just a moment, but just the very short version being, a gas or even electric resistance water heater has a lot more in common with a dragster, and a heat pump is a little more like a Prius. The gas and electric resistance water heaters are inefficient, but the amount of heat output is just a function of what's the maximum capacity, generally primarily about the maximum capacity of the device. With a heat pump, they're really function best for providing heat on a more continuous basis at a lower rate. And so you can overcome the difference between the dragster and the Prius via tank design, and I'm not going to go into that, but our next speaker will. Next slide. But I would just really, I'm going to boil this down. That means if we look at our commonly available water heating technologies, if you could advance one notch, gas tank water heaters and tankless will be banned in the Bay Area by 2031. And we need to be planning for and really systematically making progress against the transition. As Michael alluded to, the simplest solution of electric resistance is unrealistic in many cases because the operating cost or utility cost becomes prohibitive, as well as the capital cost can be prohibitive in the absence of extraordinarily excellent design. And there are a lot of resources Michael was alluding to. That was the tip of the iceberg. Resources to really improve efficiency, but we're not yet taking advantage of the efficiency on the hot water production side with heat pumps, and it's the health regulation that's in the way at the moment because there isn't specific guidance to recognize that, and that means that there's a lack of familiarity with heat pumps on the part of health regulators, and so they may decline requests to install these devices even when certain devices can comply with the current guidelines. Next slide. And so just to go into the detail there, the category of water heater that can be installed today and can comply with the current CCDEH water heating guidelines is a hybrid heat pump water heater. So it'd be probably familiar to you if you work in residential, but this is the commercial equivalent with the compressor and electric elements all on the single unit. And the purpose, as we know, is that you get some of the efficiency benefits of a heat pump, but you're backed up by electric resistance. And so the key is making sure that everyone in this type of system is aware of this technology and how it could be dealt with before we're ready to make broader changes to the health regulations. And so it really boils down to, if you'll permit or forgive a dad pun there, boils down to just looking at the electric element, the capacity of the electric element, and if that's sufficient to satisfy those health guidelines, then this type of water heater can pass, while still producing a lot of the hot water in operation via the heat pump. Next slide. And that still isn't a panacea, so we do need to do our best to support this technology where it's appropriate, but you still, due to the presence of electric resistance in significant quantity, there is impact on the electric panel and service capacity. The more, of course, the resistance is utilized in operation, and that's a function of efficient design, the higher utility cost is going to be. And there are some limits to the scale of unitary heat pump water heaters that are available. On the other hand, there are a lot of facilities that are small enough that this is a practical technology. And so examples of where it could go today, and we see one example has been found in the wild, and actually Michael was substantially contributed to its installation, is in a gelato shop in San Francisco. So that sort of scale of small or quick service facility with pretty light sanitation hot water demand can be a really excellent application and doesn't need to wait for broader technical work to update the guidelines to recognize the benefits of heat pumps. Next slide.
Barry, please wrap it up when you can. Thank you.
Thank you very much. And so we are looking for other pilot sites to where heat pump water heaters could be installed or are installed to assemble better data about their use in situ. Michael's team will be doing trainings both for environmental health professionals and for building department staff, and we'll be promoting those in the next month or so. And in San Francisco, we're working on a technical bulletin, which then we'll also share via BayREN to explain to health officials exactly how to plan check this type of device. And with that, I'm going to pass it over to Amin to hear about how we might be able to advance those regulations and better benefit from heat pumps in the future.
Wonderful. Thanks, Barry. That was a great background. It's really important to talk about the importance of sanitation for food service and, our collective efforts to update these sizing guidelines, as we really like to get heat pumps in to, help decarbonize kitchens. They also have an additional benefit of being able to cool, humidify kitchens. So talking about thermal comfort earlier, heat pump water heaters can be our additional allies in that as well. So today I'll be presenting on lab testing of heat pump water heaters to mimic restaurant hot water use. And to provide a little background, we've been gaining some momentum in the last few years. We've had 5 recent projects or active projects on commercial kitchen hot water systems, and they include a market study on heat pump assist and also a field pre and post retrofit study installing a heat pump. And also we have developed a hot water system design guide, and looking at a report where we're going to provide some recommendations for updating the health department sizing guidelines. So to go into this a little bit more, next slide, please. We're going to be looking at, before we really get into it, I just want to kind of recognize our project funders for this lab project. This is the PG&E Code Readiness Program, and they fund early research and also data gathering that really sets the stage for effective code development. And this program can really help overcome the various code barriers with new building requirements. The health department sizing guidelines is an example of that, of one of those barriers. And it can also help researchers prepare for the development of codes and standards enhancements initiative reports, also known as case reports. And these case reports summarize the need and viability of the proposed code measures and provide some code language to support the energy code rulemaking process. And that's also commonly known as the Title 24 Part 6, Building Energy Efficiency Standards. And next slide. So, we're currently in the test plan development process and lab build stage for the hot water system performance testing laboratory. And this is being conducted in San Ramon at the PG&E ATS PTAU labs. And, we're going to be testing various heat pump water heater equipment, including in this picture, you have a split system, but also unitary heat pumps and the use of different storage tanks and distribution system configurations. We're going to try to mimic the operation of hot water systems in cafes and fast food, as well as sit-down facilities. And it's going to include various types of distribution systems, including like the standard configuration that you find in your home, or it could be a continuous recirculation system that uses a pump. And as we'll show a little bit later, we'll show how we're going to be using draw stations to mimic end-use fixtures. This project is, mainly to really develop a sizing guideline for commercial kitchens. It could be used by the health departments moving forward. And it's also, will help understand energy use in these facilities and maybe support some energy code proposals in the future. Next slide. So some of the key questions we'd like to answer is, can unitary and split heat pumps meet the hot water load? Which ones and what system designs? How much energy do they consume in doing that? Also, how should these heat pumps be sized, and how much space do they need? These are the types of questions that we want to answer. And testing in the laboratory offers really repeatable testing, where we can really fix the environmental conditions, such as the ambient air temperature or the relative humidity, as well as the inlet cold supply water temperature. We can really fix those so we can have an apples to apples comparison between the various tests. And we can also have other consistent test conditions, like a specific hot water supply and return temperature, or we can really fix the heat loss rate through the piping. And we can also kind of control the recirc pump flow rates as well. So with that, can we move on to the next slide? It also allows us to try out different types of distribution systems. Like what we have here, if you look at the drawing to the right, we have 3 unitary heat pump water heaters that are set up in parallel, and they're feeding hot water with the, if you follow the red outline, to the mixing valve. In this scenario, the water heaters would provide 150-degree water that would be controlled to 125 degrees at the mixing valve, and that would then feed the distribution loop. And similarly, they reach the draw stations that are shown to the right, and then continue through the recirculation loop from the supply loop to the return loop, and they return back to either the water heater or they can return back to the mixing valve, and that would be kind of shown in this orange line. So this is kind of how we're mimicking the hot water system in the laboratory, and we can test out various types of storage tank configurations, various types of heat pumps, and use multiple units or a single unit, and potentially also use a temperature maintenance tank, which is an electric resistance water heater to control the heat loss, or to make up the heat loss in the loop. So with that, please, next slide. So in wrapping up, the phase 1 testing is going to really focus on unitary heat pumps. These are really designed for coffee shops and like small fast food. We have sandwich shops and bars. They work really well when they're not utilized with continuous recirculation systems. But what we're seeing in new plumbing drawings as restaurants are really more focused, as we talked about, of getting hot water to those hand sinks, they're starting to use a lot more recirculation systems with controls. And so it'll be really interesting to test these units with those more elaborate distribution systems. And our goal is to ensure that these units provide hot water and they do that efficiently and reliably as well. So with that, I think that wraps up the slides that I have today. Thank you so much.